What if our universe was born from inside a black hole? This audiobook invites you to explore one of the most provocative ideas in modern cosmology, that everything we see, the galaxies, time, space itself, could have emerged from the heart of another collapsed universe. A hypothesis that not only challenges intuition, but could also redefine the beginning of time and the true meaning of the Big Bang. As we explore the cosmos, an intriguing question arises: how did these enigmatic objects form? Black holes are born from the death of massive stars, those that explode in spectacular supernovae, leaving behind a collapsed core that becomes a black hole. It is a natural process, but at the same time, it serves as a reminder of how fleeting the cycle of life can be in the universe. Now, we cannot talk about black holes without mentioning the origin of the universe. Imagine a moment in time when everything we know did not exist. The most accepted theory about this origin is the Big Bang, which tells us that the universe began as an extremely hot and dense point about 13,800,000,000 years ago. Since that moment, the cosmos has been in constant expansion, like a balloon being inflated. But what connection do black holes have with this primordial event? The connection is deeper than it seems. Some scientists suggest that black holes could be portals to new universes, an idea that challenges our current understanding of reality. Is it possible that each black hole is a gateway to a new universe, a new miniature Big Bang? This concept may seem straight out of a science fiction work, but modern physics invites us to explore it. The singularity of a black hole, that point where all its mass is concentrated, raises questions about the structure of space-time. According to Einstein's general relativity, the gravity of a black hole distorts the space around it like a heavy ball on a stretched sheet. But what happens at that singularity? That is where science begins to find limits, and human curiosity faces a puzzle. Could it be that the key to understanding the universe lies in these unexplored regions? However, the information paradox takes us to a new level of wonder. If something falls into a black hole, does it really disappear forever? This dilemma has sparked intense debate within the scientific community. The idea that information is lost challenges fundamental principles of physics. Could it be that within a black hole lies a secret of the universe that we do not yet understand? With the advent of quantum cosmology, another nuance is added to this story. The theory suggests that, at extremely small scales, the universe could behave in surprising and strange ways. Some scientists have proposed that black holes may be the origin of emerging universes, an idea that opens doors to the possibility that our own universe is just one among many. Could parallel universes exist, all born from black holes? Delving deeper, we find concepts like wormholes, which could connect different points in space and time. Imagine a tunnel that traverses the cosmos, allowing instant travel from one end to the other. However, the connection between wormholes and black holes remains a topic of debate. Could black holes be the entrances to these tunnels? The possibilities are as exciting as they are unsettling. Meanwhile, the theory of quantum gravity seeks to unify two of the pillars of modern physics, general relativity and quantum mechanics. This quest is fundamental to better understanding the universe, where black holes play a crucial role. Could there be a theoretical framework that explains how the cosmos really works at its deepest level? With Hawking radiation, a revolutionary idea emerges: black holes may not be eternal. This radiation suggests that over time, black holes can evaporate, challenging the notion that they are immovable entities. If this is true, what does it mean for our understanding of the universe and its ultimate fate? Cosmic inflation, a phenomenon that occurred in the early moments of the universe, is also related to black holes. This rapid expansion could have given rise to structures that later became black holes. The possibility that a black hole could generate a new universe is undoubtedly a fascinating concept that invites reflection. As we continue to explore these ideas, it is important to consider the observational evidence that supports the existence of black holes and the expansion of the universe. Images of black holes captured by telescopes have opened a window to the unknown, providing us with a glimpse of the cosmos that previously existed only in our imaginations. On this journey through modern cosmology, we find ourselves faced with an ocean of questions, theories, and possibilities. From the nature of reality to the philosophical implications of the universe potentially arising from a black hole, each idea challenges our understanding and invites us to keep inquiring. What does all this mean for us, human beings who seek answers in a vast and mysterious universe? So as we navigate these unexplored waters, let us remember that curiosity is the engine of our knowledge. Every answer we find opens new questions, and every black hole is a reminder that in the darkest corners of the cosmos, there may be light waiting to be discovered. What secrets will black holes and the origin of the universe reveal to us in the future? The adventure is just beginning. Black holes are undoubtedly one of the most fascinating phenomena in the universe, but what exactly are they? To understand them, we must first go back in time and explore how they form. A black hole is born from the death of a massive star. When this star exhausts its nuclear fuel, it can no longer support its own gravity. Thus, the core collapses while the outer layers are expelled in an explosion known as a supernova. What remains is an extremely dense remnant, where gravity is so intense that not even light can escape its pull. This is what defines a black hole, a point in space where gravity is so powerful that nothing can escape from it. Now, what are the characteristics of a black hole? Imagine a gigantic funnel. At the center of this funnel is the singularity, the heart of the black hole, where matter is concentrated in an infinitely small space. Surrounding it is the event horizon, a virtual boundary that marks the point of no return. Once something crosses this limit, it is trapped forever. In other words, the event horizon is like a threshold that, if crossed, means there is no turning back. Unlike other astronomical objects, black holes do not emit light. This can make them difficult to detect. However, we can infer their presence by observing how they affect their surroundings. For example, if a star is orbiting a black hole, we may notice that it moves in a way that we would not expect. This movement gives us clues about the mass of the black hole, which can often be several times greater than that of the Sun. As we delve deeper into this topic, another intriguing question arises. Can black holes really grow? The answer is a resounding yes, as a black hole attracts matter from its surroundings, such as gas and dust. Its mass increases, making it even more powerful. This growth process can lead to the formation of supermassive black holes, which are found at the centers of many galaxies, including our own, the Milky Way. A notable feature of black holes is their ability to distort time. According to Einstein's theory of relativity, the closer you are to a black hole, the slower time will pass for you compared to someone who is farther away. This is something difficult to imagine, but we can think of it as a clock that ticks more slowly near a black hole. In space, time is not an absolute concept. It is malleable and affected by gravity. Moreover, black holes can be of different types. There are stellar black holes, which form from stars that have exhausted their fuel, and supermassive black holes, which are found at the centers of galaxies. There are also intermediate mass black holes, which are less common and sit between these two extremes. The variety is astounding, and we are still learning about them. But what about the matter that falls into a black hole? Does it disappear forever? This leads us to one of the most intriguing questions about these cosmic mysteries. The answer is not so simple. The matter that crosses the event horizon is in an extremely compressed state, and its fate becomes an enigma. Some scientists suggest that this matter could be transformed in some way, but exactly how that happens remains a mystery. And while black holes are dark and mysterious, they are also incredibly powerful. They emit radiation in the form of X-rays when they attract matter, creating bright accretion disks that are visible from astronomical distances. This radiation not only helps us detect black holes, but also provides information about their behavior and the matter surrounding them. Recent studies suggest that black holes could serve as portals to other universes. This idea, although it sounds like science fiction, has captured the imagination of many scientists. If black holes can connect different parts of space-time, then they could be more than just objects of curiosity. They could be the keys to understanding the very structure of the universe. Now let's consider the possibility that black holes are not just the end of a star, but also the beginning of something new. Some theorists suggest that they could be the place where new universes are born. This idea, though radical, invites us to rethink our view of the cosmos and our place in it. As we explore more about black holes, it is essential to remember that we are still in the early stages of our understanding. Each discovery opens new questions and curiosities. Science is a continuous process, and every answer we find leads us to new uncertainties. In summary, black holes are a cosmic phenomenon that challenges our understanding of the universe. From their formation to their mysterious nature, every aspect of these objects invites us to reflect on time, gravity, and matter. As we continue to explore, it is exciting to imagine what we will discover next. So the next time you look up at the starry sky, think about these incredible black holes and the profound mystery they represent. What do we really know about the origin of the universe? To answer this question, we must delve into one of the most fascinating theories of modern cosmology, the Big Bang theory. This theory tells us that the universe, as we know it, has not always existed in its current form. In fact, it began as a singularity, an extremely small and dense point, which expanded in a burst of energy and matter about 13,800,000,000 years ago. But how did this transformation from nothing to everything occur? Imagine a balloon. When we inflate it, the surface stretches and expands. Similarly, the universe began to expand from an extremely compact state. This expansion is not just the movement of objects outward, but it implies that space itself is expanding. Now, what does this mean for us? It means that every galaxy, every star, and every planet is moving away from each other. Isn't it incredible to think that we are in a universe that is constantly stretching? The Big Bang theory also tells us that in the beginning, the universe was a very hot and dense place. Can you imagine a sea of pure energy, where neither atoms nor molecules existed? Over time, as the universe expanded, it began to cool. As the temperature decreased, the first subatomic particles, such as electrons and protons, began to form. It's like when hot steam starts to condense into droplets of water. This process, although slow, laid the groundwork for the creation of hydrogen and helium atoms, the simplest elements in the universe. But how did stars and galaxies form from these elements? Imagine a vast ocean of hydrogen. Over time, some regions of this ocean began to collapse under the influence of gravity, forming dense clouds. When these clouds contracted enough, the pressure and temperature in their core became so high that nuclear reactions began, giving rise to the first stars. Each star is like a little sun shining in the darkness of space. Isn't it amazing to think that we are stardust, formed from the remnants of these gigantic fire spheres? As these stars lived and died, they released heavier elements into space. Have you ever wondered where the elements that make up your body come from? Carbon, oxygen, nitrogen, all of these elements were forged in the hearts of stars. The explosion of some of these stars, known as supernova, scattered these elements across the cosmos, creating the material from which new solar systems were formed and, eventually, life. The expansion of the universe did not stop after the formation of stars and galaxies. In fact, astronomers have discovered that the expansion is accelerating. Why is this happening? The answer is related to a mysterious form of energy that we call dark energy, which seems to be pushing the universe to expand faster. This raises intriguing questions. What is dark energy, and how does it affect our understanding of the universe? Studies on the expansion of the universe have revealed something surprising. We are not only moving away from nearby galaxies, but the most distant galaxies are moving away from us at an even faster rate. It's as if the universe is designing a magical show where each star, each galaxy plays its role in an endless cosmic dance. But what does this mean for the future of the universe? Will it continue to expand forever? Or will there come a point when everything stops and begins to contract? The Big Bang Theory, while fascinating, is not the only one that attempts to explain the origin of the universe. Other theories have emerged, including ideas about cyclical universes and multiverses. What if our universe is just one of many, each with its own rules and characteristics? Imagining a multiverse can be disconcerting, but it also opens up a range of possibilities about the nature of reality. As we continue to explore the universe, it is important to remember that science is constantly evolving. What we know today may change with new discoveries. Each advance in technology allows us to look further and deeper into the cosmos. Who knows what secrets we still have yet to uncover? The Big Bang Theory and the expansion of the universe offer us a powerful insight into our place in the cosmos. They show us that we are part of a continuous and dynamic process, where every element, every star, and every galaxy has its own story. In this vast cosmic stage, our questions about the origin of the universe are just a small spark of curiosity amidst the immensity of space and time. Isn't it amazing to think that despite how vast the universe is, we are capable of contemplating and understanding its origin? What happens at the heart of a black hole? This question has intrigued scientists and philosophers alike for decades. One of the most fascinating features of black holes is the singularity, a point where the laws of physics as we know them seem to break down. But what does singularity really mean? Imagine a pool that is draining. As the water level decreases, the pressure at the bottom increases until, at a certain moment, the water is so low that you can no longer see the bottom. In terms of a black hole, the singularity is that invisible bottom where gravity is so intense that nothing, not even light, can escape. The singularity is surrounded by what we call the event horizon. This is the point of no return. Once you cross this boundary, there is no turning back. But how is it possible for a point to have such power? The answer lies in the curvature of space-time. Think of a trampoline. If you place a heavy ball in the center, what happens? The trampoline sags and the surface curves. This is how gravity works in the universe. A black hole is like that heavy ball that deforms the fabric of space and time around it. The more massive the black hole, the more pronounced the curvature it generates. As we approach a black hole, time begins to behave in strange ways. For a distant observer, time seems to slow down as one gets closer to the event horizon. But for someone approaching it, time passes normally. This phenomenon leads us to wonder, what would happen if a traveler ventured into a black hole? Perhaps they would become trapped in a time loop, where time stops in a way we could never imagine. However, the reality is that upon crossing the event horizon, that person would be torn apart by tidal forces as they approached the singularity. And what about the information that falls into a black hole? This is where things get complicated. According to physics, information can never be destroyed. So what happens to the information of everything that falls into a black hole? This question has given rise to one of the most intriguing paradoxes in modern physics. On one hand, we have the belief that information is lost forever in the singularity, but on the other hand, quantum mechanics tells us it cannot disappear. This has led to theories suggesting that information could somehow be recovered. Could it be stored in the event horizon in some form? Now, how do black holes relate to the concept of time and space? As we mentioned earlier, Einstein's general relativity tells us that space and time are interconnected. In the vicinity of a black hole where gravity is extreme, space-time curves so intensely that it can give rise to phenomena that challenge our understanding. This peculiar behavior leads us to think that perhaps black holes are not just destroyers of information, but also gateways to other dimensions of the universe. Are there other theories that help us understand these mysterious singularities? Some scientists have proposed that instead of being an end, black holes could be a beginning. Imagine that upon collapsing, a black hole could give rise to a new universe. This idea suggests that in some way singularities could be the seeds of new cosmos, creating an endless cycle of births and deaths in the universe. Moreover, the singularity also raises philosophical questions about the nature of reality. If time and space behave in such strange ways near a black hole, what does that mean for our understanding of existence? Perhaps reality is more flexible than we think, and black holes are a manifestation of this flexibility. This leads us to reflect on the very essence of time. Is it a flowing river or a static landscape in which each moment coexists? Singularities and their relationship with space-time have also inspired many theorists to explore even more radical concepts such as wormholes. These hypothetical shortcuts in space-time could connect one black hole to another, allowing travel between different points in the universe. However, manipulating these wormholes, if they exist, is a challenge we have yet to overcome. As we advance in our understanding of black holes and their singularities, we encounter more questions than answers. Each discovery leads us to new mysteries and challenges that test human intuition. Will we ever be able to unravel the secrets hidden in the hearts of these titans of the cosmos? Black holes are more than just astronomical phenomena. They are windows into the very nature of reality. They lead us to question what we think we know about time, space, and information. As we continue to explore these mysteries, a world of possibilities opens up that could change our understanding of the universe forever. Are you ready to keep exploring? The information paradox is one of those mysteries often found at the intersection of modern physics and philosophy. What happens to information that falls into a black hole? It is a question that has puzzled scientists for decades and leads us to question fundamental concepts about the nature of the universe. To understand it, we first need to comprehend what information is in the context of physics. Imagine that information is like a book. Each page contains data about the state of a system, about what exists in the universe. Now, if that book is lost in a black hole, what happens to its content? The idea that information could disappear in a black hole challenges one of the fundamental principles of physics, the principle of conservation of information. This principle states that information cannot be destroyed, only transformed or transferred. So if a black hole swallows a book full of information, has it really been lost forever? The short answer is that we don't know for sure. And that is what makes this question so intriguing. A good starting point to understand this paradox is to imagine a card game. Suppose you have a deck of cards in your hands and decide to shuffle them. Even when the cards are in a different order, the information about the cards and their arrangement still exists. If you throw those cards into a black hole, does the information about their order disappear? Most physicists believe not. Somehow that information must persist. However, the problem becomes even more complicated with Einstein's theory of relativity and quantum mechanics. Both theories are fundamental to our understanding of the universe. But when it comes to black holes, they seem to conflict. General relativity tells us that nothing can escape from a black hole, while quantum mechanics suggests that information should be retrievable in some way. So what do we do with this discrepancy? Stephen Hawking, one of the most influential physicists of the 20th century, proposed that black holes could emit a form of radiation now known as Hawking radiation. This radiation suggests that, although black holes absorb matter and energy, they could also release energy in the form of particles. But what does this mean for the information that falls into them? Some scientists believe that this radiation could carry clues about the lost information, but others argue that, in the end, the information dissipates and is lost forever. An intense debate continues about whether the information that falls into a black hole can be recovered. Some theories suggest that it could be encoded on the event horizon, which is the boundary that delineates the black hole. Imagine that the event horizon is like a film that projects the information of what has fallen into the black hole. However, this idea also raises new questions. How could we access that information? Could it really be read, or is it simply an echo of what once existed? Another fascinating perspective is the proposal that black holes could act as gateways to other universes. In this scenario, the information lost in a black hole could be reborn in a new universe, transformed but not destroyed. This leads us to wonder, if information transforms when crossing the event horizon, could we ever understand how that transformation works? Some theorists have suggested that information could be stored on the surface of the black hole, in a way similar to how data is stored on a hard drive. This idea, known as holography, posits that all the information of a volume of space could be represented on its surface. But if this is true, how does that information translate in the context of a black hole? The information paradox also prompts us to reflect on the very nature of reality. If information can be lost, what does this imply for our understanding of the universe? Are we really sure that everything we know and have learned is safe? These questions may seem abstract, but they have profound implications for our existence and our ability to understand the cosmos. As research progresses, scientists continue to seek answers. Experiments in particle physics and studies of black holes in the cosmos are helping us unravel this enigma. Each new piece of information, each new discovery could bring us one step closer to understanding how black holes really work and what happens to the information they contain. The information paradox is not just a scientific dilemma. It also invites us to explore the meaning of loss. What does it really mean to lose something? In the context of a black hole, it could mean the transformation of information, its reconfiguration in a new space and time. This makes us think about our own lives. Do experiences and memories get lost, or do they simply change form? With each new theory and discovery, the information paradox continues to fuel the mystery of black holes. It forces us to question our own concepts of reality and permanence. As we explore these themes, we discover not only more about the universe, but also about ourselves. In this journey of exploration, the information paradox becomes a mirror reflecting our own concerns and questions about life and existence. In the vast and fascinating universe of cosmology, one of the most intriguing ideas is the notion that the universe itself could arise from a black hole. How is it possible for such a mysterious object to give rise to something as immense as the cosmos? This connection leads us to explore the concept of quantum cosmology, a field that blends quantum mechanics with the Big Bang theory and opens the door to new possibilities about our existence. Quantum cosmology suggests that the universe is not a fixed and static place, but a dynamic entity in constant evolution. Imagine an ocean in which each wave represents the creation of a new universe. Every time a black hole forms, it could be the beginning of a new wave in this cosmic ocean. But what role do black holes play in this scenario? To understand it, it is essential to remember that a black hole is not just a void in space. On the contrary, it is an extremely dense object that attracts everything that comes close to it. This phenomenon is due to its intense gravity, which is so powerful that even light cannot escape its pull. But what happens to the matter that falls into it? Does it disappear forever? Quantum cosmology offers us an intriguing answer. Studies suggest that information is not lost in a black hole but could be transformed. Imagine that matter is like a book. When it falls into the black hole, the book is not destroyed. Instead, it is reconfigured into something we cannot yet comprehend. This idea leads us to wonder if, in the end, black holes could be portals to new realities, even new universes. The possibility is raised that when collapsing into a black hole, matter could give rise to a new universe in a process similar to cosmic inflation, where the universe rapidly expanded in its early moments. Could black holes be factories of universes? This notion challenges our traditional understanding of time and space. If a black hole can give rise to a new universe, what does that mean for time itself? Time as we know it could be a completely different concept in the context of a black hole. Inside it, time could behave strangely, distorting and flowing differently. Considering that general relativity tells us that gravity can curve space-time, we could imagine that at the heart of a black hole, time could slow down to the point of almost stopping. What if in those moments, a new universe were being created in an instant? One of the most revolutionary theories in this area is the idea of emerging universes. This theory suggests that each black hole that forms could be the beginning of another cosmos, completely independent of our own. It's as if each black hole were a new Big Bang. But how can we test this theory? This is where quantum physics plays a crucial role. Subatomic particles follow rules that challenge our intuition. In the quantum world, things can be in multiple states at the same time, which means that reality could be much stranger than we think. If these quantum principles apply to cosmology, then black holes could indeed be portals to other universes, each with its own rules and characteristics. Moreover, the connection between black holes and the creation of new universes leads us to reflect on our own existence. If our universe was born from a black hole, does that imply that there are other universes, each with its own stories and possibilities? The idea of a multiverse where multiple realities coexist becomes more plausible. All of this leads us to question not only our place in the cosmos, but also the very nature of reality itself. Quantum cosmology is not only fascinating, but also raises profound questions about life, death, and the cycle of creation and destruction that seems inherent to the universe. If black holes are indeed generators of new universes, then the death of a star could be the birth of another cosmos with its own forms of life and consciousness. Exploring these ideas is not just a matter of scientific theory, it also touches on philosophy. What does it mean to be human in a universe where each black hole could be the beginning of a new chapter? This perspective can be both terrifying and liberating, blurring the lines between what we consider possible and what we do not. Thus, quantum cosmology invites us to look beyond what we see and to question what we think we know about existence. It reminds us that in the vast canvas of the universe, there is always more to discover. The connection between black holes and the creation of emerging universes is just one of the many wonders awaiting us in the mystery of the cosmos. Therefore, as we look toward the stars, we may be contemplating not only our past, but also the future of countless realities that could arise in the fabric of time and space. Quantum cosmology not only provides us with answers, but also ignites our curiosity about the infinite. Have you ever wondered what wormholes are and how they relate to black holes? These enigmatic phenomena of the cosmos have captured the imagination of scientists and enthusiasts alike. Imagine a tunnel that connects two distant points in space and time, as if you had a shortcut through the universe. That is the essence of a wormhole, a possible gateway to other parts of the cosmos or even to other universes. So how are these wormholes formed? The theory suggests that they could arise from the same matter that creates black holes. Think of a black hole as a gigantic vacuum cleaner in space that devours everything around it. When a massive star exhausts its fuel, it collapses under its own gravity, creating a black hole. If the conditions are right, this same intense gravity could, in theory, form a wormhole. But what happens inside a wormhole? Imagine you are in a dark tunnel where the walls are made of unknown matter and gravity plays by different rules. The idea is that within this tunnel, space and time behave differently. Instead of simply traveling from one place to another, you could jump between different moments in time. It sounds like science fiction, but some theories suggest it could be possible. However, the existence of wormholes raises intriguing questions. Could we actually build one? The answer is complicated. We would need something we call exotic matter, a form of matter that has unusual properties such as negative energy. In the real world, we have not found evidence of such matter. But what if it existed? What could we do with it? Imagine you find a way to create a wormhole. You could visit historical moments, meet famous figures, or even observe the Big Bang in action. However, there are also risks. The stability of a wormhole is a mystery. The theory suggests that they could collapse instantly, becoming deadly traps for any reckless traveler. And if we think of wormholes as portals, a fascinating question arises. Could they connect us with other universes? Some scientists believe these tunnels could be conduits to parallel realities, where the laws of physics might be completely different. Imagine a universe where gravity is weaker or where time flows backward. Would you dare to explore that place? On the other hand, we must also consider the philosophical implications of wormholes. If we could travel through time and space, what would that mean for our understanding of history and causality? Could we change past events? The idea of altering the past has been a recurring theme in literature and film. But in reality, the consequences could be unpredictable. As scientists continue to explore these concepts, more questions arise. How can we test the existence of a wormhole? The answer lies in observation and mathematics. Physicists have proposed models that could help identify whether these tunnels exist in the universe, but for now, everything remains speculative. Research on wormholes also leads us to consider the role of black holes. Some scientists believe that black holes could be the starting point for the creation of wormholes. When a black hole collapses, it could give rise to a singularity, and from there, the idea is that a wormhole could form. This connection creates an intriguing link between the death of a star and the possibility of new universes. In summary, wormholes invite us to dream and question our understanding of the universe. Although we have not found concrete evidence of their existence, the mere possibility that these tunnels exist leads us to reflect on the nature of reality and our limitations as human beings. The exploration of the cosmos is a journey that is just beginning, and every answer we find leads us to new questions. So, as we continue to unravel the secrets of the universe, let us never forget the wonder that surrounds us. Wormholes, though enigmatic, are a reminder that there is so much more to discover. Can you imagine a future where we can cross between universes, experiencing history from a completely new perspective? Wormholes may just be a part of a much larger cosmic puzzle, one that we are only beginning to understand. And in that journey, every question and every answer brings us a little closer to the heart of the universe. The theory of quantum gravity is a fascinating field of study that seeks to unite two fundamental pillars of modern physics: general relativity, which explains how gravity works on a large scale, and quantum mechanics, which describes the behavior of subatomic particles. But why is this unification so crucial? What secrets of the universe could be revealed by understanding how these two theories intertwine? To begin, let's consider how these two worlds interact. In general relativity, massive objects like planets and stars warp the fabric of spacetime. This curvature is what we know as gravity. In contrast, quantum mechanics deals with small particles, where uncertainty and probability are the norm. However, when we try to understand extreme phenomena like black holes, the lack of a theory that unifies both perspectives becomes a real puzzle. Quantum gravity is not just about making both theories fit together. It also seeks to answer profound questions about the nature of the universe. For example, when a black hole collapses, what exactly happens at the heart of that phenomenon? Is it possible that the information lost inside can be recovered in some way? These questions are fundamental to our understanding of reality. One approach to tackling quantum gravity is string theory. Instead of treating particles as points, string theory describes them as tiny vibrating strings. These strings can have different vibrations and in doing so give rise to the various particles we observe. But can these vibrations also explain gravity? The theory suggests that strings could interact in ways that generate gravity and, consequently, could offer answers about the nature of black holes. However, not all theories of quantum gravity are the same. Another approach is loop quantum gravity, which focuses on spacetime as a network of intertwined loops. According to this view, space is not continuous but is made up of small atoms of space. This raises an interesting question. What is the structure of spacetime inside a black hole, perhaps within it? These intertwined loops exist in a completely different way than we know. The relationship between black holes and quantum gravity also has philosophical implications. If we consider that information is not destroyed, as some interpretations of quantum mechanics suggest, then the fate of the information that falls into a black hole becomes a dilemma. Could there be a way to recover that lost information? Such questions not only challenge our beliefs about physics, but also lead us to reconsider our conception of reality. One of the most intriguing aspects of quantum gravity is how it could explain phenomena like the Big Bang. As the universe expanded, could black holes have formed that in turn generated new universes? This idea of emerging universes suggests that our reality could be just a small part of a vast multiverse where each black hole could be a doorway to another universe. As we explore these theories, it is important to remember that the search for a unified theory is not just an academic exercise. It has profound implications for our understanding of the universe and our place in it. If we manage to unravel how gravity and quantum mechanics work together, we could be on the brink of discovering new laws of physics that transform our understanding of the cosmos. It is worth mentioning that although there are many promising theories, the scientific community is still in a stage of exploration. Quantum gravity is an active field of research, and new ideas and experiments are constantly emerging. What experiments could help us validate or refute these theories? How could future observations of black holes and their properties shed light on the nature of quantum gravity? Reflecting on these questions, one realizes that science is a journey of continuous discovery. Each new theory, each new experiment brings us one step closer to understanding the mysteries that surround us. Quantum gravity is not just a quest for unification, but an exploration of the very fabric of existence. As we delve into these complex concepts, it is essential to keep an open mind. The history of science is filled with ideas that challenged conventional thinking. Who knows what revelations await us on the path to a deeper understanding of the universe? Ultimately, the quest for the truth about quantum gravity and black holes is, at its core, a search to understand who we are and what our place is in the vast cosmos. In every black hole, in every dark corner of the universe, the key to unveiling the secrets of reality itself may be hidden, and that is an adventure worth embarking on. Black holes have captured the imagination of scientists and enthusiasts alike, but what if I told you they could be more than just simple cosmic phenomena? What if they could actually be gateways to other universes? This intriguing possibility lies at the heart of the idea of parallel universes and the multiverse. The notion of a multiverse suggests that our universe is not the only one. Imagine a vast ocean where each bubble floating on the surface represents a different universe, each with its own physical laws and realities. In this context, black holes could act as generators of new bubbles, harboring within them the seed of a completely new universe. But how could something so extraordinary happen? When a black hole forms, a singularity is created, a point where gravity is so intense that matter is crushed into a tiny space. And what happens to the information that falls into that singularity? According to some theories, information is not lost but transformed. It could be that this information, when compressed, gives rise to a new universe somewhere in space-time. This leads us to wonder, could the Big Bang of our universe have been the result of a collapse in a black hole from another universe? The connection between black holes and the concept of multiverses is not only fascinating but also a challenge to our current understanding of physics. If black holes can create new universes, then how many universes could exist in the vast cosmos? The answer could be infinite. Each black hole could be a doorway to a completely different world where the laws of physics, time, and space operate differently. Now let's examine the idea that every time a black hole forms, it does so in a process that could create a new challenge for physics. The theory of cosmic inflation suggests that in the initial moments after the Big Bang, the universe experienced exponential expansion. If we apply this idea to black holes, we might imagine that the collapse of a massive star into a black hole could be the catalyst for a new inflationary process in an emerging universe. But how does this connect with the famous Hawking radiation? Stephen Hawking proposed that black holes are not completely black. In fact, they can emit radiation and eventually evaporate. This suggests that, in a sense, the matter that falls into a black hole does not disappear forever, but could release that information back into the cosmos. Perhaps in a new universe, the evaporation of a black hole could be the spark that ignites the creation of a new universe. What if one of those new universes were one where the laws of physics are completely different? Perhaps in that universe, time flows backward, or gravity does not exist at all. The possibility of parallel universes opens a range of questions about the nature of reality itself. What does it mean to exist in a multiverse? Could there be versions of ourselves in those other universes living completely different lives? The theories about parallel universes and black holes also lead us to reflect on the fate of our own universe. If black holes are indeed portals to other worlds, does that mean our universe could also be the result of a black hole? The idea that we are living in a universe that is the product of another is both astonishing and perplexing. Science fiction has explored these ideas thoroughly, but real physics is also beginning to glimpse these possibilities. Are we on the verge of discovering that our reality is just one of many, each with its own peculiarities and laws? The boundary between science and fiction becomes blurred when we consider the vastness of the multiverse. However, not everyone is convinced that these theories are correct. There are criticisms and skepticism about the idea that black holes could be generators of new universes. Some scientists argue that while these ideas are intriguing, they lack empirical evidence. Is it possible that we are chasing theoretical illusions without a solid foundation in observational reality? The quest for answers to these questions is a fascinating journey. As we advance in our understanding of the cosmos, each new discovery could bring us closer to answers about the multiverse and black holes. Modern physics is constantly evolving, and with it, our perception of reality transforms. The concept of parallel universes raises questions about our own existence and the meaning of life. If there are indeed infinite universes, what is the purpose of ours? Are we here by chance, or is there a design behind our reality? These philosophical questions invite us to reflect on the nature of our existence in the vast cosmos. As we continue to explore the mystery of black holes and their possible connection to parallel universes, let us remember that each answer may lead us to new questions. After all, the universe is a place full of surprises, and who knows what is yet to be discovered in the vastness of space. The adventure is just beginning, and human curiosity will take us to places we cannot yet imagine. Hawking radiation is a fascinating concept that has changed our understanding of black holes. But what does it really mean? To break it down, we first need to imagine how a black hole works. These giants of the universe are known for their ability to attract everything that comes near them, even light. But what if I told you that although they are known for swallowing everything, they can also expel something? This is where Hawking radiation comes into play. Stephen Hawking, an extraordinary theoretical physicist, proposed that black holes are not as black as they seem. According to his theory, quantum mechanics plays a fundamental role in their behavior. Imagine that in the empty space where there is nothing, there is actually a whirlpool of particles and antiparticles that constantly appear and disappear. These particles are ephemeral, but their existence is a crucial part of quantum reality. As one approaches the boundary of a black hole, known as the event horizon, surprising things can happen. If one of these particles appears right at the edge and its partner is absorbed by the black hole, a sort of escape is created. The escaping particle becomes what Hawking called Hawking radiation. But why is this so important? It means that black holes are not eternal. They can lose mass and eventually evaporate. Think of a balloon losing air. With each small escape, the balloon gets smaller. Similarly, a black hole can gradually lose mass over time. This challenges the traditional idea that black holes are the absolute end. Instead, they can be a stage in a continuous cycle of transformation. Now consider the implication that black holes evaporate. What happens to all the information that fell into them? Quantum physics tells us that information is never lost, but the fate of that information in a black hole poses a profound paradox. If a black hole completely evaporates, where does the information go? This question has led to heated debates in the scientific community. Some physicists suggest that the information could somehow be released through Hawking radiation. Others, however, believe it could be lost forever. This dilemma has led to the formulation of new theories that attempt to reconcile quantum mechanics with general relativity, creating fertile ground for future research. Hawking radiation also offers us a new way to conceive of the universe. If black holes can evaporate, that suggests that at some point they could be the origin of new phenomena. Some scientists speculate that as they evaporate, a black hole could create a new universe, similar to an egg giving life to a new bird. This idea is as intriguing as it is complex, and it opens the door to the possibility that our own universe could have originated from a black hole in another cosmos. The notion that Hawking radiation not only affects black holes but may also be fundamental to our understanding of the universe is astonishing. If black holes can generate new matter and energy through their evaporation, it means that the cosmos is a dynamic and ever-changing place where the death of one star can give rise to the life of another. To visualize this, imagine an endless cycle of creation and destruction. Black holes, instead of being the villains of space, could be the catalysts for new beginnings. This invites deeper reflection on the nature of reality and the cycle of birth and death in the universe. Of course, all of this leads us to ask, what does this mean for us? The idea that we are connected to a much larger web of existences and universes could change our perspective on life itself. If black holes can pave the way for new universes, perhaps death is not the end, but simply a change of state. Finally, Hawking radiation is not just a scientific curiosity, but a reminder that there is still much to learn about the universe. Each discovery opens new questions, and each answer leads to new explorations. As we delve deeper into the mystery of black holes and the radiation they emit, we get a little closer to understanding the complexity of the cosmos we inhabit. The search for answers continues, and who knows what revelations await us along the way. Have you ever thought about how the universe began? What if I told you that this primordial spark might be related to a black hole? In this section, we will explore a fascinating idea: cosmic inflation and its possible connection to the notion that a black hole could be the origin of a new universe. Cosmic inflation is a concept that refers to an extremely short but intense period of expansion of the universe right after the Big Bang. During this phase, it is believed that the universe grew at an astonishing rate, as if a balloon were being inflated in an instant. In this brief span, the small irregularities that formed during that initial expansion could have given rise to the structures we observe today, such as galaxies and galaxy clusters. But what does this have to do with black holes? To understand the relationship, let's think of black holes as the doors of a tunnel connecting different realities. At the heart of a black hole lies a singularity, where gravity is so intense that nothing can escape, not even light. Imagine a time machine that not only absorbs everything that approaches, but could also be creating something new inside. This is the idea that many scientists are exploring. In the theory of cosmic inflation, it is suggested that at the end of a black hole's life, a phenomenon could occur in which its energy and matter reconfigure, creating a new universe. This new universe could start in a state similar to that experienced by our own universe at the beginning, right after the Big Bang. But what does this mean for us? The notion that a black hole could be a generator of universes raises profound questions about our existence. If there are many black holes in the cosmos, could there be multiple universes being born from them? The idea of a multiverse, where each black hole acts as an incubator for new universes, leads us to think about the infinite possibilities of existence. Each black hole could be a gateway to a new reality, a new set of physical laws, and a new destiny. Imagine for a moment that every time we look at the starry sky, we are not only seeing stars and galaxies, but also the potential parents of new universes. This transforms our perspective on the cosmos. Instead of being an empty and desolate place, the universe could be a hotbed of constant creation. However, this idea also sparks great debate in the scientific community. Some physicists argue that the theory of inflation and the creation of universes from black holes is too speculative. How can we be sure that this really happens? The the answers are not straightforward and require observational evidence that we have yet to obtain. Science advances by leaps and bounds, and each new discovery can change our understanding of reality. On the other hand, research on black holes and their connection to cosmic inflation also leads us to rethink fundamental concepts such as time and space. If a black hole can give rise to a new universe, does this mean that time can be cyclical? Could our universe be just one of many that occur in an endless cycle of cosmic births and deaths? These questions are both philosophical and scientific. Moreover, we cannot forget that the idea that a black hole can give rise to a new universe also has implications for the nature of reality. If each black hole is a portal to a different universe, what does that mean for our understanding of the universe we live in? It invites us to reflect on the uniqueness of our existence and our place in the vast cosmos. As we delve into this fascinating intersection between black holes and cosmic inflation, it is essential to remember that we are in an exciting moment of scientific discoveries. Every day, new data and theories emerge, challenging our beliefs and expanding our vision of the cosmos. Research on black holes and their role in the creation of universes is one of those fields that, although still developing, offers us a glimpse of how incredible the nature of the universe can be. So as we look up at the stars, let us remember that each bright point might not just be a distant galaxy, but also a possible cradle of new universes. In this vast and mysterious cosmos, black holes could be not only the devourers of matter, but also the creators of new realities, offering a new meaning to the word origin. The search for answers to these intriguing questions continues, pushing us to explore beyond the limits of our current understanding. What evidence do we have of the existence of black holes? This question has intrigued scientists and curious minds alike. Black holes, those mysterious objects in the universe, have left a significant mark on the path of human knowledge. But how do we know they really exist? The answer to this question lies in a combination of astronomical observations and physical theories that have evolved over the years. One of the key pieces of the puzzle is gravitational waves. These tiny vibrations in the fabric of space-time were first detected in 2015 by the LIGO Observatory. This discovery not only confirmed the existence of these waves, but also provided direct evidence of the collision of two black holes. Imagine a pair of marbles on an elastic surface. When they collide, they generate waves that propagate. This is how gravitational waves work, and their detection has completely changed our understanding of the cosmos. But that's not all. The way black holes interact with their environment also offers us clues. Astronomers have observed how stars move at high speeds around an invisible point in space. This phenomenon is similar to how planets orbit around the Sun. If we observe a star moving very quickly and on an unusual trajectory, it could be that it is being influenced by a black hole. This cosmic dance becomes an indication of the presence of a massive object that we cannot see. The radiation emitted from accretion disks, those rings of matter that swirl around a black hole, also provides us with valuable information. When matter approaches a black hole, it heats up to extreme temperatures and emits radiation in the form of X-rays. This luminous flash becomes a signal that telescopes can detect. Thus, astronomers can identify supermassive black holes at the center of galaxies that seem to be devouring everything around them. Even more fascinating is the study of galaxies. Observations show that almost all galaxies, including our own, the Milky Way, have a supermassive black hole at their center. What does this mean? If black holes are an integral part of the structure of galaxies, their existence is not only probable but almost inevitable. This opens the door to a better understanding of how galaxies formed and evolved over time. The effects of black holes on the cosmos are not limited to the matter around them. They also affect time and space. Einstein's theory of relativity teaches us that the gravity of a black hole can distort time. Imagine a clock that ticks more slowly near a black hole compared to one that is far away. This curiosity is not only a fascinating concept, but has been verified through experiments showing how time behaves differently in intense gravitational fields. computer simulations have also played a crucial role in our understanding. Scientists have created models that replicate how matter behaves near a black hole. These models not only help predict what happens in these extreme regions, but also provide a framework for interpreting observations made in space. Through these simulations, we have been able to see how black holes might influence the formation of larger structures in the universe. The images provided by the Event Horizon Telescope, which captured the shadow of a black hole for the first time in 2019, are a visual testament to its existence. This milestone was monumental, as it showed the silhouette of a black hole at the center of the galaxy M87. The scientific community celebrated this achievement as one of the most significant advances in the history of astronomy, offering a tangible representation of what was once only theoretical. However, the path to the acceptance of black holes has not been without controversy. Initially, many scientists doubted their existence. The idea of an object that does not emit light and consumes everything that approaches seemed too extreme. But as evidence accumulated, skeptical voices began to fade. What does this tell us about the scientific process? It reminds us that science advances through observation, questioning, and the constant re-evaluation of our beliefs. Moreover, the study of black holes has opened new questions in the field of physics. If these objects are so fundamental to the structure of the universe, what else could they teach us? Research continues. Driven by human curiosity and the desire to understand the unknown, each new answer generates more questions, and that is the engine of science. Observational evidence not only supports the existence of black holes, but also invites us to reflect on our place in the cosmos. With each discovery, with each new image, we are closer to unraveling the mysteries of the universe. The search for truth is endless, and black holes are a fascinating part of this story. Finally, when looking at the starry sky, it is easy to get lost in the vastness of the universe. Black holes are reminders that there is so much more to discover, that the wonders of the cosmos are waiting to be revealed, and as we continue our quest for knowledge, each finding brings us one step closer to understanding not only black holes but also the very origin of the universe. Science advances, and with it, our understanding of the reality that surrounds us. The idea that the universe could arise from a black hole is fascinating and at the same time perplexing. How is it possible that something as immense and complex as the universe can emerge from such a dense and dark point? To understand this, we must first explore the notion of an emergent universe. Imagine we are in a vast and unknown ocean, where each wave and current represents a different universe. In this ocean, black holes are like whirlpools that absorb everything around them, and from those whirlpools, a new world could emerge. The idea that the universe could be born from a black hole is based on the theory that gravity, when collapsing a massive star, leads to a black hole that in turn could create a new spacetime. This leads us to an intriguing question. What is inside a black hole? Scientists believe that at its core lies a singularity, where the laws of physics as we know them cease to apply. It's as if we are at a point where time and space are distorted, making any attempt to understand what happens a monumental challenge. A concept that helps to understand this idea is that of the space-time bubble. Imagine that the universe is an expanding bubble, and that a black hole acts as a kind of valve. When matter and energy fall into it, they accumulate and could, in theory, create a new universe in a process that resembles the creation of a soap bubble in a bath. This new universe could be different from ours, with its own laws of physics and unique characteristics. The notion that a black hole can be a generator of universes raises a series of questions. If this is true, how many universes have already emerged from black holes? Could we be living in a universe that is the result of the collision of other previous universes? The idea of a multiverse, where multiple universes coexist, becomes increasingly plausible. Like an infinite library, each book would represent a different universe, all connected in some way through black holes. An interesting aspect of this theory is the relationship between matter and information. When something falls into a black hole, it seems to be lost forever. However, some scientists suggest that information is not lost but rather encoded in a way that we do not yet understand. This leads us to a new question. Could the emerging new universe contain information from its predecessor? The idea that a universe could carry the memory of another is undoubtedly an intriguing concept. The theories about emergent universes are not only speculative, they are also supported by research in theoretical physics. Many scientists are working to find evidence that supports the idea that black holes can create new universes. This involves developing mathematical models and simulations that explore how this process might occur. Science often advances through the formulation of hypotheses and the search for evidence, and this area is no exception. In the pursuit of truth, criticism and skepticism also arise. Some voices in the scientific community argue that the idea of emergent universes is too speculative and lacks solid foundations. However, the history of science is full of theories that once seemed absurd but eventually became accepted and proven. Could this be one of those revolutionary ideas? Moreover, it is important to consider the philosophical implications that arise from the notion that the universe could emerge from a black hole. If each black hole can be a generator of universes, what does this mean for our understanding of life and existence? It invites us to reflect on our own reality and the place we occupy in the vast cosmos. The idea that we could be just a bubble in an infinite ocean of possibilities is certainly a thought-provoking notion. The concept of emergent universes also leads us to question the nature of time. If a black hole can give rise to a new universe, does this mean that time is cyclical? Could there have been a universe before ours that, in turn, gave rise to others? Thinking of time as a cycle rather than a straight line can radically change our perception of the past and the future. With each new theory, scientists attempt to unravel the mysteries of the cosmos. While some focus on creating mathematical models, others seek observational evidence that supports the existence of these phenomena. Current research is centered on the search for black holes and how their behavior might reveal clues about the creation of new universes. In this context, it is essential to remain open to new ideas and perspectives. Science is a constantly evolving field, and what seems impossible today could become our next great revelation. Research on emergent universes from black holes is not only an attempt to understand the cosmos but also to comprehend our place within it. In summary, the idea that a black hole could be the cradle of new universes invites deep reflection on the nature of reality. It challenges us to think about the complexity of the cosmos and the infinite possibilities that may exist beyond our current understanding. As we advance in exploring these concepts, let us remember that every question we ask can open the door to a new universe of knowledge. Is it possible that the universe we know is just the product of a black hole? This idea may sound strange, but when we delve into the philosophy behind cosmology, it begins to make sense. When contemplating the vastness of the cosmos, fascinating questions arise. What does it really mean to exist in a universe that could have formed from the singularity of a black hole? What implications does this have for our understanding of life, time, and reality itself? The notion that our universe could be the result of a black hole is not just a scientific curiosity, it raises profound philosophical questions. Considering the possibility that everything we know has emerged from an infinitely dense point, we confront the idea that our existence is, in a way, an echo of a much larger process. This concept invites reflection on the place we occupy in the vast tapestry of the cosmos. The idea of an emerging universe leads us to question the very nature of reality. If a black hole can give birth to a new universe, what does that mean for the notion of time and space? In everyday life, time seems linear, but in the context of a black hole, time could behave in ways we cannot imagine. Could it be that our experiences of time and space are merely illusions conditioned by our limited perspective? Philosophy also ventures into the realm of existence. If life and the universe are the result of a process that begins in a black hole, then the essence of our reality might be connected to something much larger and more mysterious. Are we in some way linked to the singularity of those black holes? This line of thought suggests that our lives, thoughts and emotions could be part of an eternal cycle of creation and destruction. The possibility of emerging universes raises questions about the fate of our own existence. If the universe can arise from a black hole, what happens to the end of our universe? Some scientists suggest that there could be an endless cycle of universes that are born and die, leading to the idea that our lives are just a chapter in an infinite cosmic story. Does this mean that our actions and decisions have an impact beyond our understanding? Furthermore, the idea that the universe originates in a black hole invites us to reflect on the concept of singularity. In a black hole, the laws of physics as we know them cease to apply. What does this mean for our understanding of reality? If the singularity is the point where everything we know collapses, could it be that our understanding of the universe is also limited by our own perceptions? The philosophical implications of the universe potentially arising from a black hole are not just intellectual, they also affect our vision of the future. By accepting this possibility, we confront the idea that human knowledge is merely a small fragment of a much broader truth. Are we prepared to accept that what we consider reality may be just a tiny part of a much greater whole? The relationship between black holes and life itself also raises questions about the nature of consciousness. If the universe can arise from the compression of matter in a black hole, could it be that consciousness also originates from broader cosmic processes? The connection between humanity and the universe may be deeper than we think, suggesting that our individual experiences are intertwined with the history of the cosmos. Every time we look at the starry sky, we should ask ourselves, what stories do those stars tell us? Perhaps they are echoes of other universes, born from distant black holes whose singularities have given rise to new worlds. Could it be that our stories are merely reflections of a constantly evolving universe? Exploring these philosophical ideas also leads us to consider the ethics of our existence. If our life is the result of a cosmic process, what are our responsibilities toward the universe and ourselves? Understanding that we are part of a larger cycle could drive us to care for our planet and the lives we inhabit. Finally, the conception that the universe could come from a black hole invites us to embrace uncertainty. Science and philosophy often intersect in their attempts to understand reality, and in doing so, they remind us that knowledge is a constantly evolving journey. What new revelations await us as we delve deeper into this fascinating connection between black holes and the origin of the universe? In summary, contemplating the possibility that our universe is the result of a black hole places us at a crossroads between science and philosophy. This journey compels us to question what it means to exist and to understand that reality is a phenomenon much more complex and mysterious than we could imagine. Exploring these ideas not only enriches us intellectually, but also connects us more deeply with the cosmos and with ourselves. The perception of time is an enigma that has fascinated humanity since time immemorial. When we think of time, we often visualize it as a straight line that moves forward endlessly, where the past is behind us and the future is ahead. However, the presence of black holes introduces a completely new perspective on how we experience and understand time. Have you ever felt that time stops in moments of great emotion? That feeling may seem trivial, but in the context of relativity, it becomes a profound concept. Black holes have the ability to distort time in a way that challenges our understanding. As we approach a black hole, time begins to behave strangely. From the perspective of a distant observer, time for an object approaching a black hole appears to slow down. Why does this happen? The answer lies in the intense gravity of a black hole. According to Einstein's theory of relativity, gravity not only affects objects but also influences time itself. This phenomenon is known as time dilation. Imagine an astronaut approaching a black hole while a friend observes from afar. To the friend, the astronaut seems to move slower and slower as they near the event horizon, the point of no return of the black hole. However, for the astronaut, their own clock continues to tick normally. In their reality, There is nothing strange about their temporal experience. This strange behavior of time raises intriguing questions. What does the future really mean when gravity can alter our temporal perception? If a traveler ventured to the edge of a black hole and then returned, would they bring back a different future than those who remained behind? The idea that time can be manipulable based on our location in space is perplexing but also fascinating. Let us reflect on how this might relate to the origin of the universe. If we consider that the universe itself may have emerged from a black hole, then the nature of time in the universe would have profound implications. It could be that time as we know it is not a universal constant, but rather a result of the structure of space and gravity in our environment. In this sense, time could be a product of how matter and energy manifest in the cosmos. The idea that time is relative also invites us to reflect on life itself. Often we find ourselves caught in daily routines, feeling that time slips through our fingers. But what if time is just an illusion created by our perception? If time can be manipulated by cosmic forces, then what does it truly mean to live in the present? The theories about black holes make us question our understanding of reality. The notion that time can be different depending on gravity and speed leads us to wonder if we are truly living in the same time as those who are far from us. This idea extends to how we perceive life, relationships, and our experiences. On the other hand, time dilation also suggests that the future may be a more elastic concept than we think. In a sense, every moment we live could be part of a broader temporal fabric, where the past, present, and future are interconnected in ways we do not yet fully understand. Could it be that our decisions and actions in the present have repercussions in a future we have yet to experience? The relationship between black holes and time invites us to explore the possibility that the universe is not a static place, but a space in constant transformation. Perhaps time is not a straight line, but a cycle that repeats, where each black hole acts as a portal to new realities and temporal experiences. In this sense, each black hole could be a starting point for a new universe and a new perception of time. As we continue to investigate the mysteries of black holes, we also face philosophical questions about our existence. If time is so malleable, what role do we play in this vast cosmos? After all, we are observers and participants in a universe that seems to play with the rules of time in ways we are just beginning to understand. So, as we reflect on the nature of time and its relationship with black holes, we can find comfort in the idea that, although time may be a deceptive construct, our experiences are real and meaningful. Each of us, in our own realities, contributes to the complexity of the cosmos and the fabric of time, making every moment count, no matter how fleeting it may seem. Exploring these themes not only helps us better understand the universe, but also prompts us to question our own lives and the meaning we give them. Ultimately, the relationship between time and black holes invites us to open our minds to the infinite possibilities of the cosmos and the wonder of existence itself. The nature of reality is a topic that has fascinated philosophers, scientists, and curious minds throughout history. What is reality really? Is it a fixed stage where we all play our roles, or is it something more fluid, like a river that never stops moving? In the context of modern physics, and particularly black holes, these questions take on a new dimension. When we think of a black hole, we often visualize it as a cosmic monster that devours everything around it. But what does this mean for our understanding of the universe? Black holes are not just points of no return. They are portals to a new way of understanding reality itself. Imagine a place in the universe where the rules we know seem to fade away. In the vicinity of a black hole, time behaves strangely, as if it were in a game of distortions. The gravity of a black hole is so intense that it can curve space-time in unimaginable ways. This raises an intriguing question. Is reality as solid as we believe, or is it rather an illusion influenced by gravity and time? In this sense, a black hole can be seen as a mirror reflecting the limitations of our perception. In its proximity, the line between what is real and what is possible becomes blurred. Einstein's general relativity tells us that gravity is not just a force, but a manifestation of the geometry of space-time. This suggests that our reality is intertwined with the way we experience time. Could it be that time, as we understand it, is simply an illusion created by the structure of the universe? Black holes invite us to question this. As we approach one, time seems to slow down, as if the universe were playing hide and seek with us. The concept of reality becomes even more intriguing when we consider quantum physics. In this realm, particles can exist in multiple states at once, and observation can alter the outcome of an experiment. So if reality at the quantum level is so ephemeral and changing, what implications does this have for our perception of reality in the macrocosm? Black holes, being considered as possible generators of new universes, challenge the idea that the reality we know is all there is. The notion that a black hole could give rise to a new universe suggests that reality is like a plant that can grow and branch out in different directions. Each black hole could be a seed of a new cosmos, leading us to wonder how many universes could exist in the vast cosmic ocean. Are we living in a single universe, or are we part of a constantly expanding multiverse? As we explore these ideas, we also confront the question of consciousness. If reality can be so variable and subject to change, how does our consciousness relate to it? Is our mind capable of encompassing the complexity of a universe that could be just a small part of a much larger structure? The relationship between black holes and our perception of reality could be the thread that connects our existence to the fabric of the cosmos. The existence of black holes also leads us to question the limits of our knowledge. As science advances, we discover that there are aspects of the universe that we still do not understand. Black holes are a reminder that no matter how much we learn, there is always more to explore. Reality may be stranger than we imagine, with multiple layers that we have yet to unravel. Throughout history, humanity has sought to understand its place in the cosmos. Black holes, by challenging us to reconsider the nature of reality, offer us a new perspective on our role in the universe. Are we destined to be mere observers, or is there a deeper purpose behind our existence? This question resonates as we reflect on the interconnectedness of all things. The challenge is to accept that our understanding of reality may be just a small part of a much larger whole. Black holes, as portals of mystery, invite us to broaden our vision and consider the possibility that there are realities we have yet to imagine. Could it be that our quest for knowledge leads us to discover that reality is much richer and more complex than we think? With each astronomical discovery, we get a little closer to unraveling the secrets of the universe. However, each answer also brings new questions. What does all this mean for us as a species? Black holes remind us that, despite our advances, there will always be a horizon of knowledge to explore. The true nature of reality could be a puzzle that is never fully completed. Ultimately, the relationship between black holes and our understanding of reality challenges us to keep curiosity alive. What other secrets does the universe hold? The quest to understand reality is an ongoing adventure, and black holes are just one of the many stops along this path. Each discovery, each theory, brings us a little closer to what it truly means to exist in this vast and mysterious cosmos. So the next time you look up at the starry sky, remember that there is much more than meets the eye. Reality, like a black hole, may contain infinite surprises waiting to be discovered by those who dare to look beyond the obvious. The nature of reality remains an enigma, and perhaps deep down, that is what makes life so wonderful. What are the ways in which scientists attempt to unravel the mysteries of black holes? The answer to this question is fascinating and has led many to explore the universe not only through telescopes but also through experiments and complex simulations. In this journey, we delve into a world where imagination meets science, where the most abstract ideas come to life through research. One of the main tools researchers use is computer simulations. These simulations allow them to model how black holes behave and how they interact with their surroundings. Imagine playing a simulation video game where you can alter conditions and observe the results. Similarly, scientists create virtual environments where they can play with variables such as the mass of a black hole, its rotation, and the matter surrounding it. These simulations are crucial as they often show us phenomena that we cannot directly observe in the cosmos. Black holes are entities so dense that their gravity can trap even light. But how can we study something we cannot see? This is where gravitational waves come into play. Imagine throwing a stone into a pond. The waves that form on the surface of the water are similar to the gravitational waves generated when two black holes merge. Detectors like LIGO and Virgo have managed to capture these waves, providing us with a new way to see the universe. Each time a black hole merger is detected, a window into the past opens, yielding valuable data about their nature. An intriguing aspect of the research is how black holes affect the matter surrounding them. When a star gets too close to a black hole, it can be torn apart by its gravity in a process known as spaghettification. This phenomenon is not only impressive but also allows scientists to study the material found in the accretion disk, a kind of ring of gas and dust that orbits the black hole. By analyzing the light emitted by this material, researchers can learn more about the composition and behavior of black holes. But what about laboratory experiments? Although we cannot recreate a black hole on Earth, we can simulate some of its properties using quantum systems. For example, some experiments have attempted to emulate Hawking radiation, a theoretical phenomenon suggesting that black holes can emit particles and thus lose mass over time. By studying quantum systems in the lab, scientists seek to better understand how physics operates under extreme conditions. Particle physics also plays a crucial role in our understanding of black holes. In facilities like the Large Hadron Collider, particle collisions are generated at extremely high energies. Through these collisions, scientists attempt to discover new particles that could relate to dark matter or even to black holes. These investigations are essential for building a more robust theoretical framework that connects cosmology with particle physics. Next-generation telescopes have also changed the way we observe the universe. Imagine a telescope that can capture images of the shadow of a black hole, as the Event Horizon Telescope did in 2019. This historic image not only showed that black holes exist, but also provided information about their size and environment. The more images we obtain, the clearer the picture becomes of how black holes form and evolve. As technology advances, so does our ability to explore different wavelengths of light. Telescopes operating in the infrared or X-ray allow us to observe phenomena that are not visible to the naked eye. For example, the X-rays emitted by material in a black hole's accretion disk can reveal details about its temperature and density. Each new discovery opens up new questions and possibilities for research. A fascinating question that arises in this context is, could black holes hold secrets about the nature of time and space? Some scientists are working on experiments that seek to understand how a black hole's gravity affects time, something that could provide clues about the very structure of the universe. This type of research is not only exciting from a scientific perspective, but also challenges our conceptions of reality. Each finding about black holes raises new questions. For instance, when studying Hawking radiation, we wonder, what happens to the information that is lost when something falls into a black hole? This question has led to intense debates in the scientific community and has inspired theories that attempt to reconcile quantum mechanics with general relativity. On this exploratory path, collaboration among scientists from different disciplines is essential. Physicists, astronomers, and mathematicians work together to develop theories and models that explain what we observe. Conferences and interdisciplinary discussions are the breeding ground for new ideas and innovative approaches. The quest for answers about black holes is not just an academic endeavor, it also sparks curiosity in people of all ages. Many are drawn to the beauty and mystery of the cosmos, and the idea that a black hole could be a gateway to a new universe is as evocative as it is intriguing. Each new discovery has the potential to inspire the next generation of scientists and dreamers. Perhaps in exploring black holes through experiments and simulations, we are also seeking to understand our place in the universe. Each answer leads us to new questions, and each question is another step toward knowledge. What secrets will black holes reveal to us in the future? Research is ongoing, and the adventure is just beginning. At the end of the day, human curiosity about the cosmos is what drives science forward. An endless journey into the unknown. The idea that our universe could have emerged from a black hole is fascinating, but it is also a concept that has generated criticism and skepticism in the scientific community. Why do some people doubt this hypothesis? To understand this, it is essential to explore the different perspectives surrounding this theory. One of the main points of criticism is the lack of direct evidence supporting the idea that black holes are generators of new universes. It is often said that black holes are like cosmic traps, where matter and information disappear without a trace. However, if a black hole can create a new universe, where is the proof that this actually happens? The answer is that, so far, science has been unable to observe or measure such a phenomenon conclusively, leading many to question its validity. Furthermore, current physics offers us a limited understanding of what happens inside a black hole. When we talk about the singularity, the point where gravity is so intense that nothing can escape, we enter a realm where the known laws of physics cease to apply. It is somewhat like exploring the unknown in a labyrinth. There may be paths we haven't seen and unexpected turns. However, the absence of a clear map generates uncertainty and therefore skepticism about claims that entire universes could be born there. On the other hand, some critics argue that the notion of universes emerging from black holes is more a matter of philosophy than science. An intriguing question arises. If a black hole can give rise to a new universe, does that mean there is an infinite number of universes, all generated by black holes? Some scientists view this idea as a theoretical exercise rather than a solid scientific theory. The boundary between cosmology and metaphysics becomes blurred, raising dilemmas about the nature of reality itself. Skepticism also stems from the complexity of the theories involved. The idea that a black hole could be a gateway to another universe implies a series of conditions and principles that are not always easy to understand. People tend to distrust what they cannot visualize or verify. How can one conceive of something as abstract as a universe emerging from a singularity? For many, this sounds more like science fiction than real science. Some scientists wonder if this theory is based on a misunderstanding of quantum physics. Quantum mechanics and general relativity are two pillars of modern physics, but they often seem to be at odds. Could it be that the idea of emerging universes from black holes is simply a way to attempt to reconcile these theories rather than a physical reality? The search for a unified theory that explains both the macroscopic and the microscopic is a challenge we have yet to overcome. Another aspect of skepticism focuses on the lack of a robust theoretical framework connecting quantum cosmology with the existence of black holes as generators of universes. Although there are interesting proposals, many of them are still speculative and lack general consensus in the scientific community. This leads to the question, how can we accept a theory if there is no clear approach to support it? Criticism also arises from the difficulty of conducting experiments that could verify or falsify the idea that a black hole generates a new universe. Science relies on observation and experimentation. But how can one investigate something that occurs on such vast scales and under extreme conditions? The lack of adequate tools to study these phenomena adds another layer of skepticism. The history of science is full of examples where initially rejected ideas were eventually accepted. However, the path toward accepting the idea of black holes as generators of new universes is still uncertain. The evolution of scientific knowledge is a slow and often tumultuous process, full of ups and downs. Each new theory must withstand the weight of scrutiny to prove its validity. It is important to remember that skepticism is not necessarily negative. In science, questioning and deeply analyzing is fundamental to progress. Doubt and criticism are engines of research and discovery. So, is it fair that the theory of black holes as the origin of new universes is subject to criticism? The answer varies depending on whom you ask. But what is clear is that these discussions are essential for the development of knowledge. Ultimately, the question of whether the universe could arise from a black hole remains open. Science is advancing by leaps and bounds, and what seems impossible today could be part of our understanding tomorrow. Human curiosity drives us to delve into the mysteries of the cosmos, and in that journey, skepticism acts as a compass guiding us through the unknown. So, as we explore the idea that our universe might have emerged from a black hole, it is vital to keep an open but critical mind. The pursuit of knowledge is a journey, and each question we pose brings us a little closer to the truth of the cosmos. Who knows what discoveries await us on the horizon? Science is in constant evolution, and we, as curious observers, are here to follow every step of this fascinating journey. Have you stopped to think about what the future of black hole research and its relationship to the origin of the universe will be? The questions we ask today could be the answers of tomorrow. In a field as fascinating and mysterious as cosmology, every discovery opens new doors, and each door that opens brings with it a torrent of new questions. What will the next decade hold in the quest to understand these cosmic giants? Scientists are increasingly convinced that black holes are not just gravitational traps, but also centers of intense activity that could hold fundamental clues about the nature of the universe. How are these giants perceived in the scientific community? Many researchers believe that studying them could unveil secrets that have been hidden since the beginning of time. With each new observation, curiosity drives scientists to delve into theories that once seemed far-fetched. Technology is advancing by leaps and bounds, with more powerful telescopes and more sophisticated observation techniques. Astronomers are beginning to capture information that was previously simply invisible. Imagine being able to hear the gravitational waves emitted by black holes as they merge. This type of detection is opening a new field of research that could revolutionize our understanding of physics and the cosmos. What other wonders will the universe reveal to us as our technology becomes more advanced? When it comes to black holes, theories tend to become increasingly complex. However, there is a growing trend towards simplification. Scientists are looking for ways to explain complex concepts in a more accessible manner. Is it possible that in the not-too-distant future we could have a clearer understanding of how black holes relate to the beginning of the universe? Outreach and education are undoubtedly key tools for paving the way toward greater understanding. Computer simulations are also playing a crucial role in research. Scientists create virtual models of black holes and their interactions with spacetime, allowing them to observe phenomena that could not be captured otherwise. What new insights could emerge from these simulations? The possibility of seeing how a black hole affects its surroundings, even how it might influence the creation of new universes, is fascinating and could change the way we think. However, not everything is a clear path. Research on black holes faces skepticism, and not all scientists agree on how these issues should be approached. Some argue that there are more questions than answers, and that certain theories are difficult to test. How will science advance if there are fundamental disagreements about what we should investigate? Open and critical dialogue is essential for the advancement of knowledge. It is interesting to note that the debate about the nature of black holes has also begun to attract the attention of philosophers and thinkers from various disciplines. What does it really mean for us as a species if we discover that our universe could have emerged from a black hole? Such philosophical questions are becoming increasingly relevant in the context of modern cosmology and invite us to reflect on our existence. The idea that black holes could be generators of new universes raises questions about the nature of reality itself. If a black hole can give rise to a new universe, does this mean that there is an infinite number of universes waiting to be discovered? This concept of the multiverse is gaining popularity and could be a fertile ground for future research. How will this affect our understanding of time and space? As more observational evidence accumulates, the scientific community is beginning to piece together parts of the puzzle that once seemed disconnected. The relationship between black holes, Hawking radiation, and cosmic inflation is an area that promises to generate much discussion in the coming years. Could it be that everything is interconnected in a way that we do not yet fully understand? International collaborations are becoming the norm. Institutions from around the world are joining forces to study these phenomena, which means that the future of black hole research is more promising than ever. Science advances when we share knowledge and resources, and this is something that scientists are beginning to understand better. What new alliances will be forged to unravel the secrets of the cosmos? In this sense, education and outreach remain vital. The next generation of scientists and thinkers will need the right tools to tackle these challenges. How can we inspire young people to become interested in astronomy and physics? The answer may lie in how we communicate these ideas and discoveries. An accessible and exciting approach can spark curiosity and motivate many to explore the universe. The possibilities are endless. And every answer we find seems to lead us to more questions. As we move toward the future, it is essential to keep an open mind and a curious spirit. What unexpected discoveries might be just around the corner? The scientific community is ready to face these challenges and explore the unknown. Finally, research on black holes and their relationship to the origin of the universe is not just a field of study, but an invitation to question what we know about our existence. Each new finding brings us a little closer to understanding our place in the vast cosmos. Are we ready to embark on this journey of discovery and wonder? The answer to that question could define the future of science and our understanding of the universe. The possibility that the universe may have emerged from a black hole is an idea that, although it seems straight out of a science fiction novel, is supported by theories and concepts that invite us to reflect on our existence and the place we occupy in the cosmos. What if I told you that each black hole could be a gateway to a new universe, a space where the laws of physics reset and where history begins anew? This concept, both fascinating and terrifying, leads us to rethink not only how our universe was formed, but also the destiny that awaits it. The connection between black holes and the birth of new universes is not just a scientific curiosity. On a cosmic scale, it raises profound questions about time, reality, and the continuity of being. Is it possible that upon falling into a black hole, matter and energy do not disappear but are recycled into a new world? I invite you to imagine this endless cycle of creation and destruction, where each black hole becomes an incubator for new universes. The idea that the universe could have such a drastic origin leads us to question our perception of time. If we consider that time behaves differently in the presence of a black hole, then what does the word beginning really mean? Is the Big Bang the start or merely a transition from one state to another? Like a river flowing through a changing landscape, time could be a constant journey flowing from within a black hole into new realities. This notion of emerging universes is not just a fantasy, it is grounded in modern physics and theories that are still under development. Quantum gravity, for example, seeks to unite two seemingly opposing worlds: general relativity and quantum mechanics. In doing so, it provides us with tools to understand how a black hole could be the key to unraveling the mystery of our own origin. But what does this mean for us, human beings in our small corner of the universe? The idea that we could be part of a multiverse where each black hole generates a new bubble of existence also leads us to reflect on our uniqueness. Are we alone in this vast ocean of realities? Or conversely, are we one of the countless universes that arise and fade into the darkness of space? This perspective is not only exciting, but can also be a bit daunting. The notion that our reality is just one among many can make us feel small, almost insignificant. However, this insignificance can be liberating. If each black hole can give rise to a new universe, does that mean our lives have a purpose beyond what we can comprehend? Perhaps our actions and thoughts reverberate through dimensions we have yet to explore. Human curiosity, driven by the desire to understand our place in the cosmos, may be the engine that leads us to discover these hidden truths. Reflecting on the possibility that the universe emerged from a black hole also brings forth philosophical implications. What does it mean to be a conscious being in a universe that could be the result of an endless cycle of creation? This questioning invites us to look within ourselves and find meaning in our experiences, not despite the vastness of the cosmos, but because of it. Science and philosophy, although often seen as opposites, can unite in this exploration. Research on black holes and quantum cosmology not only seeks to understand the universe, but also our role in it. The questions that arise are deep and challenging. Are we the sum of our experiences or something more? Can the knowledge we acquire throughout our lives influence the creation of new universes? In the end, the possibility that the universe emerged from a black hole takes us on a journey through time and space. It invites us to contemplate not only how we got here, but also where we are headed. This journey is ultimately a reflection of our own search for meaning, connection, and understanding in a universe that, while vast and enigmatic, is full of wonders. So as we look to the future, it is essential that we embrace curiosity and exploration. Science should never cease to question, to challenge our perceptions, and to open new doors to understanding. Every black hole we observe in the sky could be a reminder that the pursuit of knowledge is endless and that each answer may lead us to new questions. The conclusion is clear. The universe is a mysterious and fascinating place. The idea that it may have emerged from a black hole is just the beginning of a broader conversation about the nature of reality. What other secrets does the cosmos hold for us? What new truths are waiting to be discovered at the intersection of science and philosophy? The exploration has only just begun, and each of us has a role to play in this grand narrative.